Today I want to share with you a device I installed at a friend of mine's country cabin. He has a gasoline power generator to run an immersed water pump, but he had to be watching for the water tank to be full in order to kill the generator. Otherwise, next thing he knew, the water would overflow the tank. I looked into the all parts box and I found a solution. A 220 volt coil relay. Both the generator and the pump work on 110 volts, but the relay coil gets DC from the diodes and it goes as high as 150 volts DC, so it's better to use a higher voltage coil. 4 1N 4007 diodes connected as a bridge. I'll explain later about this. 2 40 microfarad capacitors, 450 volt. 1 100 ohm resistor, half a watt. This guy helps protect the diodes by softening the surge into the capacitors. The idea is the following. The generator has a stop button for killing the gas engine. This button has to be pressed and held for a few seconds so the generator comes to a stop. Otherwise, it may start again. Remove the cover and attach a couple of cables to the button's terminals in order to extend them to the normally open contacts of the relay, so when the coil is energized, the generator engine stops. What the circuit does is charging a couple of capacitors so that when the generator stops, the relay is held by the charge of the capacitors, thus preventing the engine from restarting. The delay is about 3 seconds. As a demo, we will install a pair of electrodes to a glass cup and fill it with water, simulating the actual tank. Since we are not in the country cabin right now, as the relay is triggered, we will immediately disconnect the demo circuit in order to simulate the generator has stopped. We can see about 3 seconds elapse from the time the generator stops and the relay lets go, thus preventing the generator restarting due to inertia. That's it. Now we will see some explanatory drawings. The tank is empty and the generator is started. We turn on the pump and water comes into the tank. The tank is filled until both electrodes contact each other through the water. The AC from the generator gets to the diode bridge and is rectified into 150 volts DC. The diodes must be placed with their white bar as illustrated, otherwise they will be destroyed. This DC voltage charges both capacitors and energizes the relay. Remember, the normally open contacts are attached to the terminals of the generator's stop button. The input of the circuit goes to the live terminal of the generator through an extra contact in the pump power switch to make sure our circuit only works when pumping. The charge in the capacitors lasts for about 3 seconds, and after that the relay is released. This happens when the generator has come to a stop and cannot restart. The pump must have its own on-off switch so the generator can also be used for other purposes. Needless to say, the electrodes inside the tank must be made from some metal which does not corrode easily in order to avoid frequent maintenance. The electrode going all the way to the bottom of the tank must be connected to the neutral wire and be connected to earth ground in order to prevent electrical shock when touching the water pipes. Our circuit must be housed inside a plastic box close to the generator and not exposed to rain or dust. I hope this info is useful to you. Thanks for watching and please subscribe to my channel.